So in this lesson, 6.3, we're going to learn how to multiply a vector by a scalar. So when we multiply a vector by a scalar, let's say for example k, and what we're doing is we're changing the length of that vector. And if k is greater than 1, we make the vector longer. If it's between 0 and 1, we make the vector shorter. However, if it's negative, we change the direction of the vector. It becomes the opposite direction. Okay, so we can see that over here in our example here. Here's a vector A, and you can see how that vector changes when multiplied by a different scalar. It can either be in the same direction or in the opposite direction, but they're all either parallel in the same direction or parallel in the opposite direction. And we say that these vectors are collinear, which gives you a good way to compare any two vectors that you don't know. For example, u and v. So you can say u and v are collinear if this is true. If you can write u as a scalar multiple of v. If you can do that, then u and v are collinear, right? Which means parallel, either in the same direction or in opposite directions. So let's look at this example then. Here we have an airplane. Again, lots of airplanes. It is heading due north at 100 kilometers per hour. The airplane's velocity is represented by v. So we're going to draw all these vectors. Let's start with just v. And here's our scale. 1 centimeter is equivalent to, well, that's going to make our vectors really short. Let's say 1 centimeter is equivalent to 25 kilometers per hour. So that would mean if we were to draw 100 kilometers per hour, we need it to be 4 centimeters long. And we'll make it due north. So let's just do our examples over here. So if we make it due north, 4 centimeters long, v will look like that. So there's vector v. Okay, what about negative v? Well, we can draw negative v just by doing v, but in the opposite direction. Like this. So there's negative v. Then we have half v. Okay, well half v is going to be the same as v, just half the length, which in this case we should make 2 centimeters according to our scale. Which would look like that. So there's 1/2 v. And similarly, negative 1/2 v is the same thing, but opposite direction, like this. Is unit vectors. So unit vector can be very useful, and we're actually going to use unit vectors quite a lot during this course. So if I wanted to make a certain vector have a magnitude equal to 1, all I need to do is multiply that vector by the following scalar, 1 over the magnitude of that vector. So what do I mean by that? Well, let's take a look at this one, for example. This is vector x, and x has a magnitude of 3. So if I wanted to change this into a unit vector, since the magnitude is 3, I'm going to multiply this vector by the scalar 1/3. Okay, 1 over the magnitude of x. So when I do that, I get this vector, 1/3 x, and 1/3 x is a vector whose magnitude is equal to 1. And you can see that if we were to solve its magnitude by just doing 1/3 times the magnitude of x, where the magnitude of x is 3, and 1/3 times 3 is 1. So I'm just introducing unit vectors today and how to actually get a unit vector. Later in the course, we'll see how they can actually be useful. Our first example problem says the vectors x and y are unit vectors that make an angle of 30 degrees with each other, like so down here. Calculate the value of the magnitude of 2x minus y. Okay, well, let's draw this. So 2x would be well, twice the distance of x. I'll just use my ruler over here. X is about 4 centimeters, a little more, but it doesn't really matter. So I'll draw 2x, which will be about 8. So there's 2x. And if I want to subtract y, well, here's y, but I can think of negative y like this, just in the opposite direction, and I can add negative y. So let's add negative y. So we'll connect the tip of 2x to the tail of negative y. Let me just move my ruler out of the way, which was something like this. Forgot to measure the length, but it's about that. And therefore, what we're looking for is right here. Okay, so this is 2x. This is negative y. And this will be 2x minus y. So in this case, I connected the tip of 2x to the tail of negative y. But if you wanted to, you could have done the parallelogram, where you connect the tail, right here, both tails of 2x and negative y. The tails are connected. And we complete our parallelogram like this. Right, so that when you draw it, you draw the diagonal, connecting all tails to all tips. However way you want to draw it, you're still going to solve the same triangle. Okay, and our triangle over here, because this angle here is 30 degrees, we can sort of extend that if we simply sort of translate negative y over here like we did in our diagram. Right, there's your Z pattern. Right, so this will be also 30 degrees. So I can write that in our diagram over there, where this will be 30 degrees. Right? Now if I want to find the magnitude, I can use our cosine law, because I know side, angle, side. So the magnitude of 2x minus y squared equals the magnitude of 2x plus the magnitude of negative y squared minus 2 times the magnitude of 2x times the magnitude of negative y times the cos of 30 degrees. Okay, since these are unit vectors, x has a magnitude of 1, so twice of that magnitude will just be 2 squared. Y has a magnitude of 1, so just plus 1 squared. Minus 2, same thing, 2 times 1 times the cos of 30, which is root 3 over 2. One of these 2's will nicely cancel. 4 plus 1 is 5, so we get 5 minus 2 root 3. But that equals the magnitude squared. So to get the magnitude, we'll square root both sides. So 2x minus y, its magnitude is equal to the square root of 5 minus 2 root 3, which is approximately 1.24. Part B says determine the direction of 2x minus y. Okay, well if we want to figure out the direction, we need to figure out what this angle here is. So to do that, again, it's not a right angle triangle, so we are going to use sine law. So we can write the sine of theta, right, over the magnitude of that opposite side, which is negative y, which is just 1, because it's a unit vector, equals the sine of 30 over the magnitude of its opposite side, which we calculated is approximately 1.24. Okay, rearranging, well, this is just 1, so we're just left with sine theta equals sine 30 over 1.24. So theta is the inverse sine of the sine of 30 over 1.24, which is about 24 degrees. So what we can say then is it is 24 degrees rotated clockwise from 2x. Right? That's how we would identify that, because we're not using a compass coordinate here. The question never specifically said north, east, south, or west. So all we can say is 2x. Therefore, 2x minus y has a direction, kind of running out of room here, of, can I scroll over more? No. Okay, sorry, I'm running out of room, of 24 degrees rotated clockwise relative to x. So example 2 says simplify the following expression. Now to do this, let me just go back. We're going to have to look at some properties of vectors, which are fairly intuitive, but I should mention them just to make sure. One is the commutative property, which is, well, a plus b is the same as b plus a. And you can draw out those vectors. I think I actually had you do it in homework yesterday or the day before. And you might have noticed, oh, it gives you the same vector. Also distributive property with a scalar. So if you have k multiplied by bracket u plus v, where u and v are vectors, k can be distributed through that bracket to give you ku plus kv. The associative property, right, ab times a vector is the same as a times the vector bv. And of course, for any vector v, this is just an identity property. So we can use these properties to help simplify this expression. So first I can use the distributive property, and I could send this 3 throughout the brackets, and the same with this -1. And we'll get 6a plus 3b plus 3c. And then same with the negative, minus a minus 3b. And then double negative plus 2c. Okay, then I can use a commutative property, and I can factor, essentially. So I can look at like terms like here and do 6 minus 1, a, plus, well, here we have 3 minus 3, b, and 3 plus 2. Fairly simple, but just you should know that you can do this with vectors. So 6 minus 1 is 5a. This gives us a vector, and 3 plus 2 gives us 5c. Now 0 vectors exist. We don't need to write them because it's a 0, but just like the number 0, they do exist. Plus 5c. So example number 3, I don't know why. I think I was doing a different problem, and so I put a diagram, and then I changed it when I made the handout. So this diagram does not apply to this question, so I just like crossed it out there. So here's our example. Given that the magnitude of u equals 4 and the magnitude of v equals 5, and the angle between these two vectors is 120 degrees, determine the unit vector in the same direction as u plus v. Okay, I'm going to move over, find some space down here. So let's draw this. Now first it said their magnitudes and that they are 120 degrees apart. So let me see what this looks like. So let's say this is U, and I believe V was a little bit longer and about 120 degrees apart, like this. Okay, so if we were to add these, this is already nicely set up to finish our parallelogram because both tails are connected. So let's finish the parallelogram best that I can here. And then we connect tails to tips. So this is U plus V. And this vector over here was V. All right, now if we're looking at this, here's our triangle that we can solve right here. And since this is a parallelogram, this angle would be 180 minus 120, which would be 60 degrees. And this up here is an equal vector to V. So I can certainly solve for the magnitude using the cosine law. So the magnitude of U plus V squared equals the magnitude of U squared plus the magnitude of V squared minus 2 times the magnitude of U times the magnitude of V times the cos of theta. So in our triangle, the question said magnitude of U is 4 and V was 5. So we have 4 squared plus 5 squared minus 2 times 4 times 5 times the cos of 60, which is 1/2. I'll just write cos 60 for now. Okay, 4 squared, 16, plus 5 squared, 25, gives us 41. Minus 2 times 4 is 8, times 5 is 40, times the cos of 60, which is 1/2. 40 times half is 20. 41 minus 20 is 21. Then remember that is the magnitude squared. So to get the magnitude, we take the square root of that, which is root 21. And we did that because, remember, for vectors, let me go back to our previous page, to find a unit vector, we need to multiply this vector by 1 over its magnitude. So we have the magnitude now. So what's left is, zoom in, right, to create our unit vector. To create unit vector, multiply by, sorry, my writing is awful, 1 over this magnitude that we just calculated for. So we get 1 over root 21 multiplied by that vector, which we were trying to find our unit vector for, U plus V, which gives us 1 over root 21U plus 1 over root 21V. And this 1 over root 21U plus 1 over root 21V is a unit vector in this direction for U plus V, which is what the question asked for.